Hi grade 12s, welcome back to another one of our video lessons. Today we're going to carry on with Unit 4, Measuring Temperature, and we are on page 174. Alright, so here we're going to deal with temperature. We're going to introduce Fahrenheit and Celsius as the two scales of measuring temperature, and then we're going to also convert that to Kelvin, and I'll explain what that is and why we use it. Alright, so I'm going to read the first paragraph of your textbook, and then we'll get into the exercises. So the unit of measurement of temperature are degrees Celsius and degrees Fahrenheit. The temperature at which water turns to ice or freezes is 0 Celsius, and the temperature at which water boils is 100 degrees Celsius. So for the Celsius scale, those are our bottom limits. 0 is the freezing point, 100 is the boiling point of water. Okay, and then we built our thermometer based on that. Fahrenheit works on another principle which we're not going to discuss right now. The instrument we use to measure temperature is called thermometer. Old-fashioned thermometers were often made of glass with mercury or another liquid inside, but these days many thermometers are digital. There are different types of thermometers that we use for different purposes, but they all measure the temperature of something. Alright, so just a quick reason why did they put mercury into thermometers is that mercury is it's a metal, but it's a liquid metal, okay? And when you heat it up, it expands quite a bit. So that's what they use. So as you put the thermometer, say, in your hand and it starts heating up, the metal starts expanding, and obviously there's more metal, and it starts climbing up that the thermometer, that little glass tube in the middle, okay? But now the problem with that is that you break your thermometer and you got poisonous mercury everywhere, and yeah, it's a real problem. Anyway, so the thermometers that we use are in your ovens. So when you want to preheat your oven, that's usually Celsius. And also your digital thermometer to put under your arm to measure your temperature. Okay. Alright guys, we're not going to do exercise 9. So that is just basically going through how to use the thermometer and measuring your temperature and measuring temperature in class and so on. So you're more than welcome to give that a try if you want to for fun, but it's not necessary. Okay. The units we use in South Africa to measure temperature are degrees Celsius. In United States, they use degrees Fahrenheit. If you look carefully at the picture of a thermometer on the next page, you will notice that the 20-degree value on the two scales do not represent the same temperature. One unit of temperature on each scale is not the same as one unit on the other. So meaning that the scales work in different ways. It's not that 1 degree Celsius is equivalent to 1 degree Fahrenheit. Okay, and I'll show you how to convert these just now. So if we carry on reading on page 175, so the relationship between the values on the two scales is represented by the following formula. So we've got two formulas that we're going to use to convert between Celsius and Fahrenheit. Okay, so the first formula gives us the Fahrenheit. So Fahrenheit in degrees equals to 9/5 degrees Celsius plus 32. Okay. And then the other formula is Celsius equals, in degrees, 5/9 into Fahrenheit minus 32. All right, and that's also in degrees. Okay, guys, so what these two formulas are basically telling us bless me. So basically what these two formulas are telling us is that we can go from one temperature to another. So let's say we are in United States and they measure temperature in Fahrenheit, but you don't know what the temperature in Fahrenheit is. You know that it's 30 degrees Celsius in United States, wherever you are right now. Okay. So how do we convert that to Fahrenheit? Well, all we do is we substitute the value for Celsius. So we know that today it's 30 degrees Celsius, so we're going to put a value of 30 in there. So this will equal to 9/5 into 30 plus 32, okay? And that will equal, well, 30 divided by 5 is 6. 6 times 9 is 54. 54 plus 32 is 86. Okay, so 86 degrees Fahrenheit Okay, and don't forget the degree symbol. Okay, guys, so if I give you the temperature in Celsius, plug it in, get your Fahrenheit. If I can ask the same question in reverse, I can say, right, the temperature in Fahrenheit is 86 degrees. What is it in Celsius? Well, we're going to use the Celsius formula. So Celsius equals 5/9. Plug in the value for temperature here, which is 86. So it will be 86 minus 32, and we should get the same answer. Okay, we can try it. So 5/9 into Fahrenheit temperature is 86 minus 32. Okay, what does that equal? 86 minus 32 is 50, 56, 54. So it's 5/9 times 54 over 1. And that equals, so what can we do? We can divide by 9 here. Divide by 9, we'll get a 6. 5 times 6 will give us 30 over 1, which is just 30 degrees Celsius. Okay. Well, actually, we have the degrees over there, so that's fine. We can just say degrees. All right, guys, so it does work. So whichever way you go, you can always use the correct formula. These formulas will be given to you in your tests or exams, so it's just picking the right one and using it. Okay. All right, guys, so that is how we convert from temperatures. So that is essentially the worked example on page 175. Okay. Right, so I want you guys to do exercise 10. So in exercise 10, number 1, they said draw up a table of values showing the values of various temperatures in Celsius. So I want you to find the corresponding temperature in Fahrenheit. And then for question number 2, plot those. So if I find a point like this, so if I find that 30 degrees Celsius corresponds to 86 degrees Fahrenheit, that is one of the points, right? And I'm going to plot that point on the system of axes that they have drawn for us on page 175. So you guys can copy that out into your book and just plot those points. The idea here is to maybe get a straight line relationship showing you how does the scale correspond, or how does it go forward. Okay, so I want you to do that for number 2. Number 3, from your graph, read off the Celsius values. Okay, so the rest of the questions is just asking you to read off the graph and answer what's going on. Okay, so give exercise 10 a try. So you guys, I just want to blow my nose quickly. I actually have a pause. Okay guys, let's continue. So then what I want you to do is go to page 176. We're going to look at exercise 11. So I'll run through the questions, I'll explain what you have to do, and you guys are going to do it. Okay, so number 1 says, the table below shows the information provided by an American website showing the weather in different cities around the world for a particular day. All right, so we have various cities, we have maximum and minimum temperatures, okay, in Fahrenheit. 1.1, what were the maximum and minimum temperatures in all of these cities in degrees Celsius? Okay, obviously you have to use the formulas from the previous page and convert Fahrenheit to Celsius. 1.2, during which time of the year was the weather report published? So look at the pattern, look at northern hemisphere, southern hemisphere, and figure out when this happened. Number 2, the dials of some electric stoves are marked in Fahrenheit. These correspond to Celsius. The table below shows the approximate conversions. Okay. 2.1, calculate the missing temperatures labeled A and B in the table. Okay, guys, look at the table, figure it out. There's a pattern. 2.2, why do you think all the values are rounded off to the nearest 10 degrees? Okay, so think about what appliance we're using and what we use it for. 2.3, the Celsius values for 325 Fahrenheit and 425 Fahrenheit are given differently from the others. Why do you think that is? Okay, so think about that, explain. 3, the ideal range of temperatures for the inside of a fridge where food is stored is between 1.8 Celsius and 4 degrees Celsius. At these temperatures, the growth of bacteria slows down, but the food will not freeze. Use a thermometer to measure the temperature inside a fridge at home or at school, if there is one. Okay, so guys, if you can measure your fridge thermometer temperature, do it. If not, then just pick a number between 1.8 and 4, and then use that to answer the questions if they use it. Okay. 3.2, find the measures of central tendency and the lower and upper quartile values. Okay. 3.3, adjust the settings on the temperature dial of the fridge until the temperature inside is in the middle of the ideal temperature range. Okay. So, guys, you need to figure that out. Try to see if you have a thermometer, see what your different temperature measurements are in your fridge by changing the settings. Okay. Right, let's now look at the Kelvin temperature scale. So that is 177. So now Kelvin is a measurement of temperature often used in physical science, and it is usually used with degrees Celsius. Absolute zero is the starting point, and then units which are units which are the same size as degrees Celsius are used. Okay, so what they're trying to tell us is that we're now not starting our temperature at zero where water freezes and then you go to negative temperature. They're saying that no, let's start our scale at zero, which is the coldest possible point we can get, and that is minus 273 degrees Celsius. That is known as the absolute zero, and it doesn't get colder than that. Okay, so they say instead of now starting at zero where it just starts freezing, we go to the coldest part, that's minus 273, and that is the 0 degrees Kelvin. Okay, so now if you look at page 177, we've added another column to our conversion tables, and now it's just saying going from Kelvin or to Kelvin. So if I give you Celsius or Fahrenheit temperature and I say convert it to Kelvin now, we use exactly this, well, not exactly the same formula, but another formula to convert. So I'll do an example for you just to illustrate that. Okay, so if we look at exercise 12, convert the following 100 degrees Celsius to Kelvin. Okay, so the formula that we're going to use is in this green block over here in your textbook on page 177. So we are going from Celsius to Kelvin. So we're going to go along the top row to the second column. So we want to use the formula Kelvin equals Celsius plus 273.15. Okay, so if we think about it, Celsius and Kelvin use the same degrees centigrade, right? Which means that all that we are doing is we are taking the scale and we are shifting it back by 270 degrees to the left, so to speak, right? So whatever temperature we get, we just add 273 to it, and then we'll have the temperature in Kelvin. Okay, so let's say we have 30 degrees Celsius, so Kelvin would equal 30 degrees plus 273.15. Or actually, no, they want us 100, sorry. Okay, well, that equals 2. Add these two together, we'll get 373.15 degrees. Okay. Right. And then there's a little Kelvin sign. Actually, the Kelvin doesn't have the little thing. Okay. Right, and then 1.2 says 100 degrees Kelvin to degrees Fahrenheit. So now we're going from 100 degrees Kelvin to Fahrenheit. Okay, so now we are going from Kelvin, so Fahrenheit from Kelvin. Okay, so hang on, we want convert the following 100 degrees Kelvin to degrees Fahrenheit. So we want Fahrenheit equals Kelvin multiplied by 9/5 minus 459.67. Okay, that's the formula we want because we have Kelvin, we want to get Fahrenheit. Okay, so degrees Fahrenheit equals Kelvin, they say it's 100 over 1 multiplied by 9/5 minus 459.67. Okay, if we work this out, so this 100 will cancel with that 5 once and 20. 20 times 9 is going to be 180. minus 459.67. Okay, so we're going to get a negative answer. Going to subtract 180 off that, so it's going to give us 279.67. Okay, so this is now the temperature in Fahrenheit. We have a negative Fahrenheit temperature. Does that make sense? Yes, because the temperature that we started in Kelvin was 100. Remember, only at 273 do we get a positive temperature. So anything below 273 is negative temperature. So yes, it is correct. We should get a negative answer over here. All right. Okay, guys, so I want you to do the rest. So question 2, look at the table and answer the questions. And once you are done with that, homework for the weekend is going to be revision on chapter 6. So that is now on page 178, 179. Okay, guys, it's a 60-minute test, so to speak. So give it a try, see how you do. Okay, it's obviously not for marks, but I want you to do it as revision. Okay, so guys, for today's lesson, what I want you to do is exercise 10 on page 175, exercise 11 and exercise 12 on page 176, 177. Okay, we've done some of them. I've discussed how to do them. They're not very difficult. And then for the weekend, I want you guys to do page 178, 179. And we'll talk about it in our Skype session next week. Okay. All right, guys. Cool. Take it easy. I hope you enjoyed the lesson, and I'll see you next time.